Okay, this is in continuation with the last. So last time we did 2.4. 2.4 I did, I think, exercise all the way from 1 to 13. Now I'm continuing with the 14. So question number 14 is about a light has sorry, a person has two lights in their well house to keep the pipes from freezing in winter. They check daily, they check the lights daily. Each light has a probability of burning out. This is the probability is given. This is the most important information. Burning, that means the bulb probability that the bulb can go off. This bulb can go off is given to you. Like suppose I call B is the bulb, represents the bulb, and then this one is um, burns out. Burns out means goes off. Okay. So what they give us is the probability that it burns out. This one is given to you 0.002. Basically, it's like out of 1,000, there there are two bulbs which could go off in 24 hours. That's what that means. Now, by just knowing this information, we can say if this is the probability of burns out, then what is the B complement? Complement means the bulb shines. So I just write the bulb shines. So that means uh, it means the probable. So this, if I want to know what is the probability of the bulb is going to shine, is the opposite of it burns out. See, so we can write it as complementary. Complement rule says we can write probability of one minus probability that it burns out. That will be. So that means this answer is going to be 1 minus 0.002. If you use the calculator, you get 0.998. Now, I just in general wrote this probability of B only. Now, this could change for the first bulb or the second bulb. See, I'm not writing that yet. So this is the main idea. Mm. So next is if the bulbs are wired in parallel. So in electrical terms, what this basically means, if this is a circuit, let's see, and this is the bulb. So this bulb and there's another bulb is they are wired in. So there's another bulb right here. Uh, So there's another bulb here. See like this, which is this also is another bulb, and they are wired this way. So this is the wire, okay, and then they are connected to the switch. So this is the switch, positive to negative, positive to negative. Electricity passes. So even if one of them fails, this the parallel basically means even one of them fails, one bulb fails, at least the other bulb will be, because the current will go here. This may go off, but it will go. The current will go here. So one of them will. So that's the important information. What is the meaning of parallel one? Now, all we want to know here is in this example, say, the bulb will continue to shine the other one if the other one burns out. It means if they are in parallel, the light will shine even if the other burns out. In this situation, compute the probability that at least one light will continue to shine. So this is important. So we want to know what is the probability that at least at least one bulb shines. At least one bulb shines. Now this is of we can write this is complement of, so we can use a complement rule. That means this is same as 1 minus probability that both burn out. Both burn out. Okay. That means now I can write in the mathematics form, that is minus probability both the first bulb, that means, and now I'm writing first one burns out. So one means first one, and this means and the second one also burns out. And we can write this as, because they are independent, so whatever this bulb with probability of this one does not affect the probability of the second one. So we can use the independent event multiplication rules as probability of A and B. If they are independent, probability of A and multiply by probability of, we can use this multiplication rule and write probability of B1 times probability of B2. Okay. So now I don't have enough room there, so let me clean this up and write the answer here maybe. Okay. So this visuals helps to understand. And I'm gonna go back here. Let's plug it in. So from here, I'm gonna write here. So it is 1 minus probability of B. So this is that the first bulb is 0.02002 times the second one is 0.002, and if we multiply, it will give you, there are three places here, so again three places, so I'll have to use six places, 0.1, 2, 3, 4, and 5, but 2 times 2 will give you 4. And then when you subtract this, it will be 0. So when you subtract this, you get 0.9995 times, and the last one will be 10 minus 4 is 6. So this is the probability that at least one bulb shines. It's very high probability. So I hope this makes sense to you. Of course, there are another different ways to do also, but I'll stick to this. Uh, let's see the second question. The second question says the lights are wired. Uh, uh, if the lights are wired in series, now what does it mean? It means instead of parallel, the series basically means the, so it means the bulb here. Let's see, this is the bulb, and then the same wire connects to another bulb. See, it means if the current does not go through the wire, if the current goes off, that means both will go off. Both will go off, right? So question is, so that means this is the understanding of that. Let me clean the whole thing so that I can make a room. And just want to write down probability that bulb uh, B means burns out E is 0.02. And then after that, we wrote it shines. Opposite of this means shines, that we have seen as 0. This is 0.2 and 0.998. So these are the main things. And because now we have the two bulbs in parallel, okay, and question says, compute the probability at least one light will continue to shine. That means for the light to burn, both should be burning, right? You can't say one will burn or other will not burn. No. So this basically means probability of at least one light continue to shine. So B part is probability uh, at least one light shines. So probability of at least one light shines basically means both should shine. That means both bulbs should shine. Both bulbs shine because they are in series, right? So remember there are two bulbs. One is here and there is another one here. So if there has to be a light, that means both will shine because the current will go through both, right? So that's why. So both will shine. So this means probability that the first bulb shines. That means this. So this is what is this stands for probability bulb shines. Bulb shines. So B1 and, and the second bulb. So B2 basically the second bulb also shines. That's raised to C. So remember this piece is probability of B. This is if the bulb burns out. This means probability that bulb probability burns out. This is burns out, right? So that means we can write and this by multiplication rule because both bulbs are independent of each other. So we write B1 complement times probability of B2 complement, the second bulb complement. But then we already worked out this as this piece we have to put both places. So this will be 0.9. So that is 0.998 times again 0.998. And if we do a little calculation, you get 0.99604. And you're done. So I hope that makes sense here to understand this. Uh, so questions like this are connected to physics, and that's why you may get confused with what is the meaning of parallel and what is the meaning of series. So you have to understand that. So if you understand that, then this becomes easier. And secondly, because they gave us there's a probability that a bulb is burning, that's why I wrote this. Bulb burns out. I mean, this probability this is burns out. So complement means opposite. So it is 0.998. The reason we did in the earlier question also, how did we get this piece? And these are the two numbers that you use right here. So instead of saying at least one light shines means both bulbs should shine. So that's the understanding this part because they are in series. So if one shines means the other one, so both shine. And then you use this. This means and. So the first one shines and the second one shines. And then you separate them multiplication rule. You get the answer. Question number 15. Can I get an okay here? Question number 15 is asking us is saying is events A and B are mutually exclusive. So what is the definition of A and B are mutually? Well, mutually basically means these are two groups like this. If I use the Venn diagram that said A and B are mutually exclusive if they don't have anything common. So A and B, the number of outcomes for both of them is empty. There's nothing. It means it is zero. It means n of A and B is zero. Now the question is find this by conditional probability by definition of what is conditional probability. This can be written as is a ratio where the B probable chances for B occurring is this down and the top one is probability of A and B. Now the denominator the probability of B stays the same but we know that A and B there's nothing. See there's nothing here. So this basically means it is 0 divided by maybe whatever the sample space, the whole sample space means the whole sample space may be n uppercase, whatever that is. So this is like n. So that means it is 0 divided by probability of B, and this answer end up to be getting 0, and you're done. Okay, question number 16 is about basketball. A basketball player makes 60% of free throws of what he attempts, 60%. So quickly we should write 60% is 60 out of 100 which is 0.6. Then, except that if he has just tried and missed a free throw, then his chance of making the second go down, that chance he goes to 30%. So 30% is 0.3. So we have to organize this whole thing. I want you to read this, pause, and see if you can do it yourself. Because the first question is you find the chance that he makes both first one as well as second. So we can define A as the problem. Let's say A is the first. Let me say, let's the first one is success. Means he does not miss. He shoots the throw in the basket, and means and B is the event that the second one he makes it success. So this is a better word to use. Now, if he fails, we will write complement. What is this basically means? That he fails. So the first he does not succeed, that means he fails. Okay. And here B complement is, and the second time he makes effort, second time also he fails here. Now let's write down the probabilities also. So the probability of A basically means the first time this one, first success is 60%, which is 0.6, and probability he fails, that means complement, right? So if he fails means it is by complement rule, it is probability of A that he makes it. That means it is 1 minus 0.60, and which is 0.4. So this is probability that he fails the first one. He fails. A complement means he fails the first time. Okay. Now let's go to the second part. The probability that P, that second success, that means B, there are two parts. If the A is a success, that means you already know the first one is success. So this part should be understood. Chances that he makes the second shot knowing that he made the first one. So this means this according to this one, it means the chances stay the same. Whatever that you have 60% here, and the first success is same as the second set. That means if the first time is he's successful, then this will be your thing. But the probability that the second one is success when you know the first one is failed. So this means the conditional problem. The first one is failed. So this time the chances of shooting or getting success is 0.30. At the same time, we need to also know. So I'll put these important informations. And next, also you should know what are that means what about chances that he fails in the second attempt when you already know that he failed the first time. So what this basically means, we can use complement, write it as 1 minus probability that he's successful when he was the second and he had failed in the first one. Right? So this means it is 1 minus, you just plug in here, this is the same thing. And if you do this, and you get answer is 0.70. So this is probability that the first time he failed, that's what that means, and the second time also he failed. So is this one. Now, question says, what is the probability that he makes both? That means this answer is probability he he is successful in the first case and he is successful in the second one by condition, by multiplication rule of probability. It is probability of A times probability of B when A has already occurred. That means probability of A is here, it is 0.6 multiplied by, and the probability of B is this piece goes right here. which is again 0.6, and the answer is 0.36, and you're done. So this is probability he shoots the first one, he's successful, and he also shoots the second one. The next question is a little trickier. Find the probability he makes at least probability at least at least one. That means he's successful either first or second. Now this means probability that it's just if at least one basically means it is one minus probability that he fails in both attempts. So this is what it fails both. And that means it is 1 minus probability. Fails basically means first time he failed, that means A complement, see, that's A complement. And he also fails the second time. We can use multiplication rule here. So the probability of A complement times probability of the second one when you know the first one. So a little tricky here. So 1 minus A complement is right here. This will go right here. So the 1 minus 0.4. And I'm going to use green color to show this piece that we have done here. This piece goes right here. So it is multiplied by 0.7. Now this will be 1 minus this will be 7 times 4 is 28. So like this. And eventually you get 0.1 minus this will get 0.72, right? And you're done. That's all it is. So that means 72% chances that he makes at least one, either first one success or the second one success. So I hope that makes sense. Okay. Okay, question number 17 says, suppose a jar contains 17 red. That means this is the jar. Okay. And there are 17 red here like this. So these are all 17 red. And there are 32 blue. So these are all 32 blue like this. All these are 32. And then you pull out two marbles without replacement. See? So you reach in the jar and pull out two marbles at random, one at a time. That means without you just pull out the first one and then you pull out the second one. So find the probability that both are red. So you're supposed to write both are red. So we can say let R1 be the first marble is red. So we can say, okay, that's the first one. Let R2 be the second one is red. Second marble is red. Okay. And we need to know what is the probability that the first one is red and the second one also red. So we can use conditional, the multiplication rule of probability, that is probability first one is red times probability the second one is red when you already know that the first one is red. So this is what it means. Now we can directly say in the beginning, total number, how many total marbles are there is, if you add 17 and 32, it is 9. Now you have 49. So the first one will be red. That means there are 49. That means out of 49, you are picking a marble, and that will be, since there are 17 of them, so this becomes out of 70. Then times, now since one of the marble is already taken off, so there will be 48 remaining. And now you want to get the second one also red. That means the first one is already red. So one of the red one is gone. One marble is gone out. That means out of 17 marbles, there will be 16 remaining. Okay. And if we do simple math here, we get this answer will give you, using the calculator, 17 times 16, and you divide by 49 times 48. you end up getting 0.1156. So that is like 11.56%. The question is there another way to do this? And you can see because you're not replacing here, that it means the first one or the second, the order matters. So if the order matters, we can also use permutation rule. That means we can say, okay, probability both red, right? Both red is directly you can use ratio of you can use NPR because permutation. That means you're pulling two marbles out. So you out of 49, so 49 P and 2. If you do this, sorry, you can write this here. And the top one is because there are 17 red, so it is 17 P2. And you work out this on the calculator, pull this out. You can directly also do and figure out what is each time we'll have to find out. Let me do 17P2. So you get 17. Let me do on my calculator. Okay. 17P2 and 49C2. If you want, we can always use the yeah, mm, maybe that's more. I'm using scientific calculator. So you want 17P2. Let's see 17P2. If we go here, here 17. It is 17, comma 2 to get that answer. And then enter, and the next one is 49P2, right? So again, I'll do the same thing, and this time we have 49, comma 2. And then you do the ratio of 272 divided by 2352. And you get the same answer, see? So this is how you can use the calculator. So another way to do, just wanted to show that. So you get the same answer, which is 0.1156. Okay, so this is more easier also. And I think we did this kind of problems. I think we did for NCR to see the winning a lottery. If you try to use you pick six numbers from some 49 numbers or 50 numbers, and what are the probability that you get at least five of them? Remember that? So you kind of do, okay, if there are 49 marbles, you see here you use the combination. And there are to pick six, these are the number of possibilities. But if you want to get five, that means you'll be getting 49. See, out of 49, you get five correct. And then after that, one of them is wrong. That means out of from 49, you take away 6, so there will be 43. So from 43, the wrong one is one of them. So if you do this, this is what we have done earlier. So this piece is almost similar. So this is yet another similar question. Suppose you write each letter of the alphabet on a different slip of paper and put the slips in a hat. So if this is the hat, let's see. And you put the slips like this. So there are 26 alphabets letters in the alphabet. So you put like this, there are 26 of them. Now from 26, from this you pick two of them. So let's find the probability that if you pull out two slips from here, so you pull out two slips from this 26. Okay, what are the chances that you end up getting the vowel, this letter, the five, any of the A, E, I, O, and U. There are five of them, right? So this is the event where it is V. So let's see the first one, or you can use multiplication rule where V1, let's write down V1 is first slip. First slip is vowel, one of the vowel, okay? And V2 is the second slip shows also vowel. Second slip is vowel. And the question is, what is the probability? The first one is vowel and the second one also is vowel. So multiplication rule says if you write probability of the first one times probability of the second vowel when you know that the first one is vowel. The first one is vowel because there are 5 of them, so it is 5 out of 26. Now, when first one is already vowel, that means from 26, how many are remaining now? 25 are remaining because you already pulled out one, right? This is all one is pulled out. So now, and because the first one is already vowel, so out of 5, there will be only 4 remaining. This will be 4. And if you work this out, do a little calculation, I think uh, you get 0.0308. That's what you get. And that's it. And you're done. So the question is there another way to do this? Yes, you could also use probability that first one is, I mean, both vowels. The first one is vowel and this means and. It means we can directly write. So there are 26. So from 26, we have how many permutations are possible is you are picking 2, see? And then since there are 5 vowels, the top one will be a number of outcomes favorable for this to be vowel. There are 5 of them. So from 5, you put 2. And you use the same thing here. This will number, I think if you work separately, this will be 20. And if you work this 26, I don't know, it will be a little a bigger number. We'll have to figure out. But then eventually you get 0.0308. Okay, so just want to make sure you guys understand both ways using multiplication rule of probability and directly using permutation formula. So this is a permutation. Using permutations also we can do. Okay, so question number 19 says a maths class consists of 25 students. So this is a class. Okay, this class contains uh, these are all together 25. 14 are female, so these are 14 female and 11 male. Now, 2 students are selected at random to participate in a probability. So that from here, 2 students are selected. Now, order matters. First one who is second because that's what they say. See, what are the compute probability chances that when you pick 2 students, so the first one and then the second one, uh, a male is selected, then female. That means first one is male and the second one is female. So we can write down, let's see, M stands for, so we could directly do this. So the question is saying first male is selected and then female. So probability, let's do like this. So probability, male is selected first. So first, instead of those letters, I can say first male and then female. So the second one is female, right? So this basically means the first male, okay, it means probability that the first one is first male times probability second one female when you already know, when you know that the first one was male. So this is how I'm writing this in words because it makes sense. That's why. Now, first one is male. Since there are 25 students, so out of 25, you are picking one student who is a male. So there are 11 male here. See, so 11 out of 20. And then after that, since the first one is already male, So that means out of 25, and one student is already male, that means there are 24 remaining. And you want to know the second one is female, see? So you want to know the second one female. So how many females are there? So it is 14. So just use the calculator. You guess 154. This will be 154. If you multiply this two, divide by 600, and you get the answer. If you want to use 154 divided by, so if I do 154 divided by 600, you get 0.2566. So we write that 0.2566. So this is 0.2566. And we can use the same idea. This is for the A part, right? We can do the same thing for the second one, probability that female first. That means when I'm writing this is the female, when you already, and then the male, right? So basically it means probability that it is female times probability, and the second one is male when you already know that the first one is female. This is another way to write to using conditional. The first time is female will be there are 25 kids and you're picking out of 14. So this will be 14 here. Now the sample space reduces to 24 students, and the second one is male. So since there are 11 males, so it is 11. And you will notice that you end up getting the same answer, 154 out of 600, which is 0.2566. Next is probability first one female and female. So if you want, you can also write first female, second female like that. So I don't want you to get too much confused. That's why. That means probability that the first one is female times probability that the second one is female, when you already know that the first one is female. Now, first one is female. How many females are there? It's 14. So it's the ratio, probably the ratio out of 25, it is 14. And the sample space reduced to 24 now. And the second one also female will be, since there were 14 females, now there will be 13 remaining. So you get 13. Okay. And if you do this, question number C, I think by mistake I did, this should be D, question number D. Okay, I'm sorry. So this is about, since I'm talking about female, so this is the answer for this. So when you multiply this, you get 154. Let me check. So, 14 times, if you use a calculator, let's say 14 times 13 is 182, and 25 times 24 is in the 600. And if you do 182 divided by 600, you get 0.3033, which is almost like 30.3%. So this is, now let's see the C I forgot. So this is probability, both males. So first one is male, and the second one also is male. So this will be probability of M1 times probability the second is also male when you know that the first one is the male. So the first one is male. So how many males are there? So first one is male. Let me show this. So first one is male, and there are 11 of them. So it will be 11 out of 25. So if it will be one less male now, and then the second one will be out of 24 kids, you're selecting the remaining 10 because it was 11, now it become 10. So this will be 111 times 10 is 110, and 25 times this is 600, and 110 divided by 600, you get 0.1833. So that's like 18.3%. And finally, we have no males. It means both females. The first one is female. So question number C, it says no males. What is the meaning means? No males means both. It means both females. Both. And we already did this here. Female, first female and second female. Question number D is same as E. So this answer that we got here is here. This is the same for the second one. Okay, I hope that makes sense. Let's go to the next one. So question number 20 is almost the same thing. Information is the same. There are 25 kids here, but out of this there are 14 female, okay, and there are 11 male. So this time you are pulling out three students, one, two, and three. So what are the chances that three students selected? The first one is male. That means I'm gonna write it here. Probability is, so we have three parts here, three commas. I'll put two commas to show the first one is male, and then the two females. That means the second one female and female. So that means your answer will be probability of first one female, sorry, male. So the first one will be male. So when you pull out this one, the first, that means that there are 11 males. So that will be 11 out of, so that will be 11 out of 25. And then you're picking, this is male, right? Then you're picking the second one. So the first one is 11 out of 25. This is like using fundamental counting principle also. That means next is there will be 24 left, and you're saying second one is female. And because there are 14 females, so there will be 14 here. And the next is, so two students are taken, then the next one also should be female. So that means one of the female is already gone. So if the second one was female, and you want the third one to be female, so there will be 13 remaining out of 14. And the total student is out of 25. So this whole thing reduces to 1001 divided by 6901 and 6900. And if I use the calculator, 1001 divided by 69, we get 0.1 0.1450, and you're done. And likewise, you can do the second one. So second one says first female. That means the first one is female, and then two males. So it is male and male. So you're going to do the same thing. The denominator will be always the same. Sorry, I made a mistake here. This is 23 here. I'm sorry, 23. Okay. So first time is out of 24, then out of 24, and then out of 23. So the first female will be female. There are 14 of them, so this will be 14. And then you want male, right? So the first, so out of this 11 male, so this will be 11, and so this will be out of 11, and this will be out of 10. And if you work that out, you get like you get 1540 divided by 1380, and if you use calculator, it becomes 1540 divided by 13800, and you get 0.111. Next is two females are selected and then one. So this is C is probability first female and then second also is female and then the male. Again, we have by fundamental counting principle, you have three probabilities here. The bottom one will be 25 first, then 24, then 23. And first female, there are 14, so this will be 14. And then the second one female will be out of 13 female, because 14 I was here. And then we have male, there are male 11. And if you multiply this one, you get, and you're going to get the same answer as this because you'll see these three numbers are the same here, you see. So you end up getting the same probability, 1450. Then comes three females. So this is D is probability getting female, female, all three females. So that means again you have my fundamental counting principle says first out of 25, then out of 24, then out of 23. The first female will be out of 14, so it will be 14, and one is gone, so 13 remaining. One is gone, 12 is remaining, and that answer you get all three males. Oh, I think they asked for. I think I'm doing this one. Let's this one three. This E. So three females will be 2184 divided by 113,800. And if I use calculator, 2184 divided by 13,800, we get 0.1582. So this is for E. Okay. Now for D, I'll have to do separate. So D is this one. Three males. Probability of getting male, male, and male. That means probability of first one out of 25 times out of 24 out of 23. So this means male there are 11. So first time it is out of 11, then one is gone, so 10 remaining. Again one is gone, 9 is remaining. So I think you end up getting the is 990 divided by 1380. So this answer, that's 990, get 0. Very small probability, 1.7. And you're done. So I hope that makes sense. This is also could be written also out of 25, you are picking 3. You could write like this also, permutations. The top one is male, there are 11, so 11p3 like this also. Because in this case, you could have also written this same thing, 25p3, and the females are 14, so you could write 14p3. But if it is like this, then two females, so it will be the bottom is remains the same, 25p3, but two females will be out of 14, so 14p2 times one male from 11, so it will be 11p1, something like that. So if you want to use permutation, you can do that, or you can do directly using fundamental counting principle and also just using multiplication rule. Now the question says a jar contains, this is 21, a jar contains 6 red marbles. So this is the jar, there are 6 of them are red. 1, 2, 3, 4, 5, and 6. There are 6 of them. And they're all numbered. Okay, 1, 2, 3, 4, 6 red and So these are 6 red, 1, 2, 3, 4, 5, 6. And there are 8 blue marbles. So this means 1, 2, 3, 4, 5, 6, 7, 8. These are 1, 2, 3, 4, 5, 6, 7, 8. The question is, a marble is drawn. So among these two, you pick one here. Probability that find the chance that the marble that is selected is going to be red or odd. So we can say, okay, let R stands for red marble, and event is red marble. Okay, or O stands for maybe odd number. Odd number. Now we want to know probability that either the marble is red or that it is odd. And this means it is probably red, union, or at least one of them should be either red or odd. So this, by addition rule, we have probability of R plus probability of O minus probability red and odd. This means and. The probability the red, because there are 6 red, so it will be 6 out of total. This total are 14 because it is 6 plus 8 is 14. So out of 14 out of 6 plus. How many are odd numbers? Now the odd numbers are, let me use the green color to show. Odd numbers are 1, 2, 3, 4, 5, 6, and 7. So there are 7 odd numbers. So it is 7 out of 14. Now you have to subtract those ones which are, I'll use red as well as odd. So red as well as among the reds, this is the red ones which are the odd. And here odd ones are 1, 2, and 3. So there are 3. So you have to take away 14. Out of 14. That means this is there's a common denominator is 14, and we just write down the numerators as it is, and you end up getting 5 divided by 7. If you use the in decimal, it will be 5 divided by 7, 0.714. And you're done. So we are using addition rule of probability. What is this? Is called addition rule. Rule of probability. Rule of probability. Now the question is, can we use directly by just looking at this here? Let's see whether we could do that. So let me take this off again. So at least it should be either it should be red or what. So first thing I will do is just add up all the red ones. These are red. There are 6 of them. And then from the other blue, this blue, you have to see which one are odd. So these are already 6. These are 6. So you look up for the other one, 6, 7. So this is odd. This is 1. So this will be 7th. This will be the 8th. Okay. 8. Then this will be 9. And this will be the 10. So that means, of course, this one I think I missed. It is 10 out of 14 here. So you could directly also do this. I'm just doing this with the help of using addition rule of probability. This is a nice formula we have this one. So that at least union means probably chances that either it is red or odd. It means you do the first one, do the second one, and subtract. Or you could just count here and figure out by directly. So question 22 also is similar. I've already showed the figure. This one contains 4 red, and you can see there are 4 red there, and 10 blue. I mean, there are 10. And you pick one of these. These are altogether 14. Now this time, find the probability that the marble is either it is blue or union It is even. So E stands for even. I can use the uh, addition rule of probability. So probability of it is blue plus probability that it is even minus probability is both blue as well as even. So first of all, how many blue are there? You can see there are 10 of them. So 10 out of 14. And how many even ones are there? So the even ones we usually use, even will be 1, 2, 3, 4, 5, and 6 and 7. So there are 7 out of 14. So 14 plus, sorry, minus, how many are both blue and even? So I have to go in the blue section. So this is the blue section. In the blue section, which one is also even? 1, 2, 3, 4, and 5. Okay. So this will be 14 common, and it is 10 plus 7 minus 5. So 17 minus 5 divided by 14. That will be 12 over 14. And if we use a calculator, 0.8571. And we are done. So the question is, without using this addition rule of probability, was it possible to figure out? Yes. So what all you can do is, look at this. We could just, I'll use the green color to show that you want to look up for those that have blue, either blue or even number. So you look up all the blues. These are 10. Okay. And in the other part, you can see this blue already done. Then you have to see for even, the other one even. So this one, this two. So this 10 plus 2 will be 12. So that's how you get 12. So you could directly also do probability of blue or even is 12 out of 14. See, direct. So question number 23 says it has 5 red, and you can see there are 5 red in the figure. 1 to 5, and there are 8 blue, 1 to 8. And you pick a marble from here. What is the probability that it is even numbered given that the marble is red? Now, what this basically means, you are being told that it is already red, and then what are the chances that it is going to be even? So this is, we can use conditional probability is a ratio where you put the R down, the red, and probability of the marble is even as well as red. Okay, now there are altogether 5 plus 8 is there are 13 marbles total. So that means which are the, how many are both even and red? So even and red. So in the red section you can see this, there are 2 here. So it is 2 out of 13, correct? And how many are red? So it is 5 out of 30. And you can see there is a 13 in the denominator for both. We can directly write 2 over 5 when you're done. So this is using probability, using conditional probability formula. But can we use uh, reduced sample space? What is reduced sample space? So is without using this reduced sample basically is based on the information provided that the ball is already red. So your sample space, the denominator out, instead of 13 marbles, it becomes out of 5 because you already know the ball is red. So what are the chances it's going to be even? So in this red, because the ball is red, out of this 5, 1, 2, 3, 4, and 5, which among them is even numbered? And you can see the even number is this and this. So 2 when you're done. So this is directly doing with the help of a reduced sample space. So we'll do the next problem directly now. B, what is B? Red. So probability that you're going to get red and it is being, and you know the number is even. It is even. So first of all, by using reduced sample space, even, how many even numbers are there? In all this, I'll just take this off because it's too much. Here it is. Look at this. These are the number, right? So just look up how many even numbers are here. And you'll see even numbers are 1, 2, 3, 4, 5. And these are even. So how many are there? 1, 2, 3, 4, 5, and 6. This is out of 6. So out of 6, which among these is even? And you can even number means 2 is even. Which one is red? Sorry. Which one is red? And you can say this one and this one are red. It is 2 out of 6. And you get answer 1/3. If you want, you can write this way also. Or if you want, you can write in fraction form and you're done. So simple, right? Or you could also do this. This is same thing actually in using reduced sample space or actually using conditional probability formula. We could write this. So this could be written as probability of red and even divided by probability it is even. So even we have already seen that there are 6 out of 13. Okay, and red and even there are 2 out of 13. So this is how you do and get the same answer here. Okay, let's do another. Okay, so question number 24, almost the same thing, but this time we have 4 red, these are 4, and 4 blue all together. There are 12 of them. We'll try to do directly. You pick a marble. What is the chance that, given that the marble that you picked is blue already, you know it is blue. What are the chances it is odd? So this is how it is. See? So now you just have to reduce to this part. That means reduce sample space as this is what is being you already know that there are it is a blue. So that means it is going to be out of 8. And out of 8, among this, how many are odd number? And how many are odd is 1, 2, 3, 4. There are 4. It is done. So it's so simple. So which is also half. You want you would write 0.5 and like that, 50%. Now look at the second question says probability that it's already told to you it is odd. So I'll write odd here. And what are the chances it's going to blue? So that means you have to look up for how many odd numbers are there. So among this, which are the odd? So among the odd ones are, so I have 1, 2, 3, 4, 5, and 6. There are 6, so it is 6 out of 6, which are blue. Which are blue. And the blue ones are 1, 2, 3, and 4. So 4 are blue. See, it's so simple. And you can divide by 2, both up and down. You have 2/3, which is 0.66666 which is 66.6%. Okay. So I hope that it takes care of this. 25. So question number 25 says compute probability of flipping a fair coin. It could be 8. And then you're doing it 2 times. So this same coin is tossed 2 times. So he's asking flipping a coin and getting heads, given that the previous flip, that means this was the first flip and this is the second flip. The sample space is going to be head, tail, tail head, and tail tail. So we can write 2 events A. Let A be the event. Previous means the first one. The first one is tail. So first tail, okay. And let B be uh, this one. This is the second. So second time. So second is head. Okay, now probability, the first is probability of A is uh, first tail. You can see the tail is first here and here. That means it is 2 out of 4. And probability the B here is second head. second head is this and this. So these are two. Again, two out of four. Now, question here is asking what is the probability that uh, it is second, that means A, when it is already told. So it says probably that the second is here, that means it is B, and it is already known to us. Previous tossing of a coin, it was tail, in tail first. Now this could be written as by conditional probability of B and A and probability of, sorry, so the top one is probability of B and A, and the bottom is probability of A. Now probability of A is here, it is 2 out of 4. And this A and B, that means it is B is second head and A is tail and head. So this means second head. So second head you have two options, right? This one and this other. Uh, among this first tail. So this is the first tail, which is 1 out of 4. So that will give you this 4 and 4 crosses and you get half. In other words, we could use also reduce sample space. Instead of, if you get confused with this, you could reduce. It is being told to us what is reduced sample space is. The probability is B, the second head. I'll just write this like this also. Second head, and when it is known, the first one is tail, right? That means you already know the first one is tail. That means how many places out of this you have second tail, and you can see second tail is here. And here, these are the two. So these two. So these are the two that have second tail. So that means there are two. And among this, which one is has head first? And you can see this is the head, which is first. So it is 1 out of 2 and you're done. So this is another way to do this. Another way to do this also is when the probability of flipping a fair coin. Even if you first time, this is like first time, and you do the second time. Now remember, these two events are totally independent. Whatever the outcome shows up in the first case does not have no effect on the outcome shows here. So let's see, that means if I write here probability of getting head, and when you are told given the previous one is tail, is same as probability of getting head in the second. It's the same thing because this tail does not affect what you get here. Whatever the outcome here has have no effect to show some affecting the whatever shows up in the second case. So this is directly related because they are independent event. So it means we could directly say, and probability of getting a head in the second one is 1 out of 2, and that's it. See, this is such a shortcut here. Also, this is also correct. It's just to show that probability of getting head in the second one, this is the second, when it is known that in the first one it is tail, this is the first, is same as probability of getting head in the second tossing of a coin. So that's and second tossing basically when you toss a coin, there are only two options, head or tail. So out of two, and head is one, so that's it. So it is head or tail. So these are two. So that's why I put two. So many different approach to do the same problem. So question 12, find the probability of rolling a die given that the last three rows. That means you're rolling a die. How many times? Hmm? Something is going wrong. Hmm? Okay. So you what is happening? Hmm. Okay, let me do it one more time. I need black marker. Okay. So if it's not letting me do, that means if I have this, okay, one. So you're doing it four times. See, when you roll dice four times, each time whatever shows, let's see, whatever shows up here has got no effect on this one, right? Whatever shows up here has got nothing to do with here, and whatever shows up has got nothing here. So these are independent events. So in the last three rows, so what is the chance that probability of getting a one on the fourth? This is on fourth, okay, on fourth. Given that the first three were rows, first three rows were one, one. Is same as probability of, I think something. So I'm gonna write it here. You see is equal to probability of one on fourth row. So that means you have dice has got six outcomes. So out of six, you get one, and you're done. Question number 27 says, suppose the maths class contains 25. So this class has got 25 students, and out of 25, there are 14 males. So this is 14. So these are 14 female and 11 males. So out of this 14 now, among the 14 itself has got three speaks French. Yeah, three speaks French. And out of males, two of them speak French. Yeah, two speak French. So complete probability that if you select a student, he speaks French, given that student is a female. So when you pick up here, probability that he speaks French, so probability of speaking French, write French, and it is being told that it is told that a student is female. So one is we can do directly using reduced sample space where now, so because you are told that it is female, so there are 14 females. And from 14, how many are French? Three. So it's done. Or you could do the other one, like you say French and female divide by probability of female. This is the conditional probability. So you get French and female. So that means this is French and female. So it is 3 out of altogether 25. And female is 14 out of 25. You can see 25 crosses out and you get 3 out of 14 and you're done. And let's do the last one. So final question, and that's the last one. I'm so tired. It says everything remains the same except the last question is probability that the selected student is a male, and it is already told given that the student speaks French. Okay? We already know the student speaks French. So how many students speaks French? You can see this is 2 plus 3. There are 5 of them. And of this, how many are male? See? So how many males are here is 2. So 2 out of 5 and you are done. So I'm using a shortcut because I'm so tired to show. So this is using reduced sample space. Okay, I hope. Thank you so much. And I appreciate you guys. Some of you are really interested, and that's why I'm making this video to help. So if there is any mistake, please bring to my attention. I know I'm going to pass sometimes and make mistakes. So hopefully this will help. And we have the last one. I'm going to do it on video on 2.5, that is expected value. What is the expected value? And we'll see that.